From Tim Oliver. This is the Tampa Bay Traffic Safety Local Academy, the Local Agency Traffic Safety Academy. Everyone received their invitation via email from GoToMeeting. A few important links on this email that I always like to show. If you have any technical questions or issues with the software, you need how to get the webinars after the fact, send me an email. Here's my contact info. Questions about the Academy itself, topics, and upcoming presentations. If you want to present the topic, that information goes to our Safety Academy coordinator, Dennis, and there is a link here as well to the Tampa Bay Traffic Safety Academy webpage. I will show that real quick, which is the location where we host all of the presentations themselves. In the Education tab, it takes you to the Safety Academy subsite, which has information about the upcoming topics. There are a few upcoming topics that we have kind of planned already for 2018. Dennis will talk a little bit more about that. Their dates are to be announced. Today's topic is here, and the presentations and video recordings of each of these webinars, as they are being recorded, are located here by year and topic. With that, one more thing. We have created in the Tampa Bay Traffic Safety Academy, the District 7 is in the process of creating a new user group for this intersection control evaluation, the topic that you will hear about today. The website is tbiceusergroup.com. It redirects you to a subsite of the Tampa Bay Traffic Safety.com webpage. It will meet quarterly in the district office during the lunch hour. They have not honed down exactly what date that's going to be, but look for more information early next year as the dates are finalized. The website will have a location where you can click on a link to give your username, your email and name if you're interested in being a part of the mailing list for joining that Tampa Bay ICE user group. That hasn't been built yet, but know that that will be there. So look for that information to be added to the website. And that user group information is over here on the Tampa Bay Traffic Safety Academy under engineering. There's an ICE user group, and we have a calendar. We have upcoming events. The calendar is blank for now because we haven't created any meetings yet. There are resources. I added a few manuals and information to the DOT web pages, and I will create a link in the future for you to join a mailing list so that you can find out more information about this. With that, I'll hand it over to Dennis for some information about the Academy and introductions of our presenter.
Good morning. This is Dennis Falloon. I'm the FDOT Local Agency Traffic Safety Academy Coordinator and Consultant, and I want to welcome you to the 14th webinar, which happens to be the last webinar for 2017. And today's Academy webinar will be ICE, Intersection Control Evaluation, by Alan L. Orr Fowley. He's a PE, and he's a State Traffic Services Program Manager in Tallahassee, Florida. He's got over 25 years of actual transportation engineering and traffic operations experience as the State Traffic Services Program Engineering. Alan directs and administers the State Traffic Services Program, which includes traffic studies, highway signing program, traffic signals, and the State Safe Mobility for Life program. In addition, I just wanted to mention there will be no poll questions in this presentation today. And also remember that there will be a survey at the end of the webinar today. And if you'd be so kind to respond to that, that would be great. With that, I'm going to give you a little bit of an introduction to the Academy. If you've seen it before, you kind of know what's coming, but if you haven't, this is the FDOT Local Agency Traffic Safety Academy, and its purpose is to provide safety topics to enhance your local safety programs. And this is the 5th year, so in 2018 we'll be starting the 6th year of the Academy, and we have a window of about 2 hours every webinar, and usually they run between an hour to hour and a half, and that includes Q&A. And Anthony already covered about registration link and where the web page is for the Safety Academy. As I mentioned, today's topic is ICE, Intersection Control Evaluation. And also wanted to mention that this webinar also provides for AICP CM credits and also professional engineer credits. Also wanted to mention about 2018. The safety topics will be posted for the first quarter of 2018 on the FDOT Local Agency Traffic Safety Academy website in the near future. And you are automatically registered to receive notices for the new safety topics. So just keep your eye out for that. Just mention also the PDHs are also provided. And with that, I'd like to go ahead and have Alan go ahead and do his presentation. Anthony?
Yep.
Okay.
You should have the prompt. There you go. We see your screen and you're good.
All right. Thank you. Thank you, Dennis, and thank you, Anthony, for the opportunity to present. And good morning and welcome, everyone. I do like to mention before I start that, I'd like to have this webinar kind of a little bit more interactive, so just to keep things interesting for everyone. I see 79 attendees, my goodness. So if you have a question, if you please note your question in the question box, so it would kind of stop me where I'm at and I can answer it. I've got about 74, 75 slides, so we have enough time as long as we, keep track of the time and make sure we address your questions. So with that, let's go ahead and get started. So this is the Intersection Control Evaluation presentation, Florida Department of Transportation. Just to give you a little bit of background, has developed this process, and we have a manual that was published November 1. The manual includes the procedure itself, and it also includes the forms that are required to be completed and the tools, and I'll go through that. So very exciting times, and with that, let's go ahead and start why we need ICE. When is ICE required? I give you the triggers, the applicability, and again, the forms and tools. You'll see the ICE manual. That is the front page or the cover page. So, we could go into a lot of debate about why we are doing this, but it boils down to the choices historically that we've been doing, changing from stop control to signalization, and the MUTCD warrants and all, and why are we doing that? Raise the awareness, increase the use of alternative intersections. Have we thought about alternative intersections? Are they safer? Consider the context classifications. Okay, so everyone knows that we are moving in that direction now. That is, FDOT's moving into something other than the rural and the urban. So we are going. This process is designed to be part of that, and we need to go into quantitative analysis and find engineering solutions that make sense, that provide not only the reasoning behind what we're selecting, but also an engineering and safety evaluation of the selections that we make. So FDOT developed this ICE, as I mentioned, ICE manual, as I mentioned, and it was released November 1. Also, if I may just go back one more time, what you see right there on the bottom is already published documents for the different types of alternative intersections that you can download from the Federal Highways website. So the purpose of ICE is really to consistently consider, context-sensitive strategies for our selection for a particular type of control and a particular type of geometry at an intersection. It makes us think about, other considerations when we're trying to make a decision as far as what type of traffic control. The safety of travel for all road users, not only just for vehicular. Context-sensitive control strategies also. So different intersection types and control types are designed for different types of environments as far as the control strategy or as far as the context classification. And again, we measure the control strategy value by using performance-based criteria, and I'll go into detail about that. So we can start with the roundabout. I'm sure everyone knows and seen the roundabout and how it operates. But what I'm trying to illustrate over here is basically ICE is going to be replacing the 3-step roundabout evaluation process in 2020. So we do have an implementation plan that we submitted and approved and signed, and that went out with the November 1 publication of the manual. And it basically spells out how we're going to implement the intersection control evaluation process. So a roundabout, just to illustrate here, we basically know that, depending on your approach to the roundabout, you can go right, you can go through, or you can go left, depending on what lane you are in the roundabout. Other alternative is a median U-turn. This is also known as the Michigan U-turn. It's been in design and operation for quite a while now. There's been some modifications to it, but the main characteristics of this type of intersection is eliminating the left turns and moving the left turns to a U-turn upstream of the road, so you can have a safer maneuver. Also, the side street or cross street traffic can make a through movement or a left turn movement by utilizing the U-turn maneuver. Another type of interesting intersection is the restricted crossing U-turn, or the R-cut. There's 2 flavors, unsignalized and signalized. And these are well-known innovative intersection types in North Carolina. They call them super streets over there, but they have been operating very well, and they're tweaked the signalized R-cuts to actually operate a little bit better than what previously was designed. So there's been some tweaks to it, and what we understand is they're very successful intersections. And the way they operate is basically eliminating the left turn from the side street. So you do have left turn ins, or North Carolina calls them leftovers, just like you would have in Thanksgiving or our holidays now. But the leftovers that they're referring to are the mainline left ends. They're signalized, so you can maneuver or make the left turn in when you receive the green ball. Another type of intersection is the jug handle. You've seen these around, and the way they operate is basically you can make a left turn maneuver by utilizing the jug handle street and actually making a left on the cross street. So you'd be able to set up your maneuver or your left turn utilizing the approach to the cross street on the arterial. A little bit different. And the displaced left turn. This one is kind of a little bit complicated, but the idea here is to allow the left turns on what you see right here is all quadrant displaced left turn, but you can have a north-south quadrant or east-west quadrant. only. And again, the main idea is to have the left turns or cross the left turns over to the other side of the through movements, so you can have the left turns and the opposing through movements trigger or move at the same time at during the green phase or during the phase. This reduces the phases of the intersection and improves the overall performance. And the way they operate, as you can see, is the approach. Either you can make a through, or you can cross over to the other side, making a left or making a right. Continuous green is something that you've probably all seen here in Florida. We do have them in South Florida. There are some, I think, there are some in District 5 also. And the way they operate is basically having a continuous movement that on the arterial, and then separating the left turn into the cross street by utilizing a left lane and signalizing that left lane. The Quadrant Roadway is another flavor. Again, it treats the left turns, and this is the common theme. We're treating, or we're redirecting the left turn movement to allow a better operation and a more safer intersection. And the way they operate is if you're coming in on the east side, eastbound movement, you would make a right to make a left, or make a right or go through. Same thing on the cross street from the north side or northbound, or east. This will be the westbound. Sorry, you can make the left by utilizing the Quadrant Roadway. And the cross street from the northbound also can utilize the left turn by utilizing the Quadrant Roadway also. So it's a different flavor. This one would require a little bit more right of way, or you can actually design these when you have closely spaced intersections in a grid design that is that we see a lot of in urban or core urban areas. So why is ICE required? Or we can say, when is ICE required here? When new signalization is proposed. Okay, so that means if we are going to change a stop control intersection, side street stop control intersection, to a signal, and it meets the warrants of the MUTCD, then ICE is triggered and is required. When major reconstruction of an existing signalized intersection is proposed, and major reconstruction, the main definition on that really resides in adding exclusive left turns, or actually blowing out the intersection and adding left and right turns. So that would be considered a major reconstruction of an intersection. And in conversion of the directional or bidirectional median opening to a full median opening is proposed. Now that, is pretty much a requirement, for any type of control that you wanted to include, because it does present some safety concerns and operational concerns. So we've added that to the requirements. Driveway connection permit applications for categories E, F, and G, or anything above E and above. And that category falls in the requirements because of a certain development that triggers the number of volume or projected volume that would kind of really closely consider, or maybe even trigger a signal warrant. So it falls into the same category of the first bullet because of the projected volume of the development. And this is similar to, let's say, a Walmart that's coming in on the main line or side street that would trigger at the main intersection the requirement for signalization. And we also added that the district design engineer or district traffic operation engineer decides that a certain intersection control or type is a good fit for the ICE evaluation process. When ICE is not required, if you have just small changes to the intersection, the milling and resurfacing, obviously, changing full median opening to a directional median opening, adding a right turn or, signal phasing changes or equipment upgrades, that's not going to trigger it. Encouraged for local roadways, not required. So, I mean, that's something that if the locals want to kind of take on this process, we certainly will help them with it, but it's not required for off system. Recommended for ramp terminal intersections, stop control, signalized or yield. That's not required. All right, who completes the forms? Obviously, FDOT staff and consultants, and then driver connection permit would be the applicant or consultant of the applicant.
Alan, there's a question about whether or not ICE is required when converting single left turns to dual left turns. Is that
that's not significant because usually the trigger for left turns is 300 vehicles making the left turn. So if that's the case, that is a minor change. Now, again, we left it to the discretion of the district traffic operation engineer and district design engineer if they think that's a good fit or would trigger a requirement for ICE evaluation. But in the context or in the, I would say, interpretation of the manual, that's a minor change.
What would you say about adding an additional through lane at a signal?
Now that is a capacity improvement for the corridor. So that would be considered a major change, yes.
Okay.
Good questions. So what you see in front of you is the stages of ICE evaluation. Now, many states have used different ways. They call them stages. They call them, different processes. But, the bottom line is the three stages, are steps that you would take to make a conscious decision of what type of control that you would want to implement in a particular location. You obviously can use the stage one if the type of control or type of intersection is I would say a no-brainer, and you can do the evaluation in stage one, and the ICE evaluation would end there if there is an obvious selection, an obvious solution. If not, stage two is kind of a little bit more detailed information that you would have to get more data for, and we'll go into that. And then stage three is a final stage if there's actually no solution or there's more detailed analysis that would need to take place, including public outreach or public meetings, environmental issues, and we'll go into that. So the ICE procedure and tools, stage 1, 2, and 3, you see the tools where they are used. Stage 1, we're going to use Capex, and Spice tool kind of straggles the two stages, and I'll go into to explain why. And then we're going to, in stage 2, it's more detailed analysis. You're going to use the guidance that we provide. We're going to use default Synchro files that we've provided, and the FDOT ICE tool. We'll go into detail about that. So the objective is to come up with one viable control strategy that fits the location. and you know, that's basically the goal. So it might be you use stage 1, it might be use stage 2 and 3, or you might need to go to stage 3. You know, we intend to make this process you know, as easy as possible, but you know, there's a lot of evaluation that's taking place. So the tools that we're providing and also the forms are designed to make it easier for the practitioner to go through the steps and make a conscious decision as far as the type or intersection control that's selected. Here's a flow chart of stage 1. You know, as you can see, we've detailed it to a certain degree. There's more detail in the manual, and there's more explanation of each step, what the practitioner needs to do, what he needs to collect. As you can see, you know, in 1.3a, there's all that data, collect and identify data related to the existing conditions. So that data has to be collected. You do the evaluation and you do the you know, filling out the forms and all that as part of this, and it walks you through step by step through the process. Here's stage 2 flow chart, similar to stage 1. It's got more detail. Each step and each bullet again is explained in the manual, and we have some resources also in the appendices for the practitioner to use if there's some question about, you know, what is the strategy or what I need to do and why am I doing this. And here's stage 3 flow chart. So I mentioned some of the resources that we have also that comes with the manual. Appendix A with information on the intersection forms. You know, we have a list of references and tools. I mentioned you saw the manuals in the front presentation slide that goes into detail about different types of intersections. In those manuals, I just want to mention briefly, FHWA manuals, they have construction sequencing, they have cost estimates that they've developed. You know, they've developed a lot of information for not only the evaluator, but the designer and practitioner that is going to be designing these intersections, and also figuring out the type of control and how to do that. The different types of intersection, you see the roundabout over here, you know, the square box over here that gives you information, the description, the vehicles, the mode of accommodation of different types of intersection, you know, the alternatives, and I'll go into detail in that just shortly. But what you would get from that red box is basically, this is a screenshot of Appendix A that has description, vehicles, pedestrians, and bicycles, and how that is considered in the you know, not only the tools but the forms that you would have to fill out. So we have Excel forms that we've developed. These we did have the forms in when we started out. We had the forms developed in Adobe. But FDOT has been moving towards, you know, Excel sheets and spreadsheets that are locked. So you know, that's we changed from the Adobe interactive forms to an Excel spreadsheet format that the practitioner will use. Actually, all the forms have a drop-down menu, you know, for different types of selections. So it's kind of, again, going back to making it easier for the practitioner to complete and you know, have that process or flow chart of what they need to do next and what they need to collect of information or data to move forward to the next step. And by the way, each step has to be approved by the district design engineer and district traffic operation engineer. Here's a screenshot of stage one's form. We go to screening. This is stage 2, control strategy assessment. And, stage 3, a little bit more detail, a little bit more data collection, but stage 3 will definitely either select an alternative, one single alternative, or provide information as far as why and not an alternative cannot be selected. So the implementation plan is designed to have full implementation in 3 years. The first year, which starts January 1, is focused mainly on district training. We are going to have district training in each district, for the district traffic engineers, district design engineers, the permit engineers, planning folks, and their consultants, obviously. And if there is space for the locals, we encourage the locals to attend. But what we're doing from the get-go here is have the training packaged so we can give it to the Transfer Technology Center and the University of Florida. The purpose of that is to have it available for the consultants or the locals for training their folks too. So we're thinking of the locals from the get-go. In 2019, let me just add. I forgot one thing about the intersections that we selected for year 1. So as part of an initiative to move this forward and have successes, we have screened intersections for each district, 2 intersections for each district that we're going to use for training. The outcome of the training is not only just to practice, but to also implement. So from the training, each district, you're going to have 2 intersections that you're going to implement the recommendations from the ICE review or the ICE analysis. And this is something that upper management has been very in favor of. And, we've talked to the secretaries, and we've talked to the directors of op and directors of development about this. So, there is funding for the districts already set aside, and we are excited and anxious to kind of get going. So this is coming your way, districts, and hopefully, the dates and the times of the training would be coming to you shortly. I'm still working with the training staff and FDOT to get those dates locked in. So it's coming. 2019, the second year, we'll ask that the districts come up with 3 intersections, preferably 1 from each of the offices that you see listed below. PD&E, traffic operations, and access management or permitting. And we'll help the districts determine those intersections, if they need any guidance or any reasoning why we're selecting those rather than others. There are some safety considerations when we select intersections. We don't want to go to the hotspot selection or the historical crash selection method. We want to go to a more predictive analysis method, and that's for everyone that has had training in the highway safety manual knows about that, and we encourage that type of network screening rather than selecting the hotspot or locations. In year three, which is 2020, full ICE procedure implementation by the districts is required. And we will start QAR in year 4. So let's get into the tools. First one is Capex. So Capex started by an FHWA's tool to evaluate the different types of alternatives, right, for capacity analysis. And it's a planning level capacity analysis or capacity assessment. So the initial operational screening of the intersection control alternatives can be used during the project scoping stage. So when we do any type of scoping or any type of assessment of intersection control, this tool is used. Now we've taken this tool from FHWA and modified it. And we made it more user-friendly, and it only requires the readily available input. So we did make the changes with FHWA's consent, because we asked them about our intentions and our desires to change Capex to include not only some different methods of how to evaluate, but also the pedestrian, bicycle, and transit information, because those are context classification or context zone classification specific. So we wanted to put that in there too, and have an evaluation, or I would say a qualitative assessment of those different types of mode of transportation. We've improved the input sheets and output comparison sheets. We've updated inputs to reflect FDOT default values, and we'll talk about that here a little bit. And then we have the HCM 6th edition roundabout capacities built in. And as you know, the roundabout capacities are kind of difficult to assess because of driver familiarity. And it's something in the if you're familiar with the HCM, you have to calibrate the roundabout in order to get a good number for the capacities. So that's done after the implementation. But a good measure or a good rule of thumb for roundabouts is considered here. We don't go into the detail of calibrating. So I don't know if you all know what the critical movement analysis is. That's something that's been traffic engineers know about it for quite a long time. That's been in our books for a long time. Many of you have done that by hand. Some of you've done it, using spreadsheets. But it's just a method to figure out the critical movement when you do have two conflicting movements or more. And that's basically the heart of the engine of the Capex tool. It estimates whether the intersection is operating below, near, or over capacity. So you will get the over C based on the critical movement. And that covers the at-grade intersections, the roundabouts, and grade-separated interchanges. So included in it's 1985 HCM and the NCHRP report 812. The Signal Timing Manual first edition also included the critical movement. So that's basically what you see right there is the initial calculation for Capex and how it takes place. This is a screenshot of the traffic volume demand tab of the tool. And it provides an opportunity for the practitioner to input the the turning movement counts. Also the percent of heavy vehicles, and if you have a volume growth that you wanted to input in there for either design year or opening year. There's also the colors that you see, the dark yellow or kind of orange color is the suggested value. Now you can override those values, but these are the recommended values that we use. That's something that we will train the managers or the approvers, so to speak, to watch for those and ask questions to why they have been changed. But the default values are Florida values that we've inputted from research and from practices that we've been doing for quite a while now. So yeah, the training I mentioned that's going to take place, we've changed the training to from a day to a day and a half. The half a day is designed really for managers, but everybody's welcome, and approvers. So these are the areas that we would want the approvers and managers look at and ask questions if there are issues. We've modified the lane configuration input tab. If you know, or if you worked with Capex before this change, you would not see this. You would have to go into individual tabs to configure the number of turn lanes or number of the lane configuration of your intersections for each of the approaches. We put it all together in one tab so it can be easier for the practitioner to input the values. As you can see, the type of intersection on the left-hand side, and then whether the configuration is full or it's southwest configuration, northeast configuration, whatever type of configuration you have, and then the number of lanes associated with the particular movement. So it's a one sheet, one area where you can put all the information in, and the rest of the spreadsheets or tabs would compute the value for you. And here's where I mentioned that you have the exhibit, or I mean the image of the intersection type. Before the change we made, what you saw there, you would have to go into this sheet and configure the lanes. You can do it anyway, the old way, but new way kind of gives you a more comprehensive look at things. This is something to aid the practitioner in not only figuring out the lanes, but also am I getting close to the volume to capacity ratio? So you can see the numbers on top. We've colored them with green, yellow, orange, and red if it's above 1. Here's the full outputs. So you would get as you can see, the V over C for the different zones. You can also get the overall V over C ratio, and then the pedestrian accommodations, bicycle accommodations, and transit. Now the fair, good, or poor is the assessment based on existing information and research that we have to date. So, anything in the future, we would be modifying this to be more of, from a qualitative assessment to a quantitative assessment. That would give the practitioner, a better feel about, where these numbers are coming from. But right now, they are from what we have today, which is basically from the Highway Safety Manual table of Chapter 12, and other documentations and NCHRP reports that we have to date that would suggest or recommend what type of pedestrian accommodations or how is the quality of the pedestrian accommodation, bicycle, or transit for any particular type of intersection that you pick or choose. And it's again, like what you see over there, signal versus uncontrolled. So you would consider the crossing width, for instance, for the pedestrians. You would consider the vehicle speed, slow versus fast, and the volume, of course, and then out of direction travel. So all of those things are considered when you select the different types of intersections and compare the pedestrian, bicycle, and transit accommodations and how that interacts with that particular type of traffic control and intersection type. So here's the summary output, giving you the ranking of the intersections based on the input that you've provided, which is basically the turning movement counts and what context zone you are, the first sheet that you saw right there. So that's the ranking, the VOC ranking shaded in blue, pedestrian, bicycle, and transit accommodation. So this kind of gives the practitioner the ranks of the intersections and which one he needs to choose to move forward if there's not a good decision as far as what type of intersection or alternative intersection is selected during stage 1. If you need to go to stage 2, you can carry over 1, 2, and 3, 2, 3, and 4, whatever the ranking and the ped, bike, and transit accommodation and the overall V over C ratio gives you. In other words, it is an engineering judgment when you carry on from this stage to stage 2 as far as what you select. It's just more of a straightforward method to select the intersection types that you want to move forward to stage 2. So I do wanted to ask some questions. These are some of the questions that I would ask to the audience, but it's more of, what does Capex analysis tell you? And I don't expect an answer from you, but I was going to give you the answer anyway. But if you have any questions on those, please, go ahead and ask them. So what does Capex analysis tell you? So it provides a method to identify viable traffic control strategy for the intersection. So the 1, 2, 3 ranking are viable traffic control strategies. How can this data be used for alternative intersection control evaluation analysis? Well, the results provide a ranking for the viable strategies and an efficient approach for the initial screening. So you can take number 1. If the district design engineer, district traffic operation engineer decides that's the way they want to go, and that would be the end of the evaluation. Or you need more data to make that decision, you move to stage 2. How is this reported in stage 1 ICE forms? Capex ranking is one of the inputs for stage 1 FDOT ICE form. So that is, again, there are some pull down menus that makes it easy for the practitioner to fill in the forms so they can then be signed by the district traffic operation engineer and district design engineer. Here's the Capex and FDOT's form stage 1, basically showing you the different type control strategies, the ranking, and we'll go into the Capex ranking here first. The SPICE is following, but the Capex rankings would go into this location. All right, moving to SPICE. Is there any questions anybody has?
Yeah, before you exit the Capex, someone with a sharp eye noticed that in the volume input tab, there is no C4 urban general context zone. He was wondering if you know why.
Which one? Which slide was that?
In the volume, when you started.
This one?
I believe so. I've got Capex open over here.
Yeah, very good question. So, can you see the FDOT context zone? To your, it's the row that says FDOT context zone, and then the zone is.
Yes, it's 62 rural on your screen.
Yeah. So if you click on that, that's a pull-down menu that will the practitioner selects what zone it is.
But in the drop-down, what they're saying is that C4.
Okay. Oh,
urban general context zone is missing.
Okay, let me make a note of that. Thank you very much.
Okay.
Okay. Not sure why, but it should have that in there. Good catch. Thank you.
Okay.
Okay. Spice tool. Spice basically is the safety performance for intersection control evaluation. That's what it stands for. It straddles stage 1 and 2 because there are some inputs required for stage 1, and if there's more detailed information that you would need for stage 2, you use it for stage 2. So safety performance for intersection evaluation. You know, again, the vision and need for this tool. We are comparing intersection types for safety purposes here and how they perform safety-wise. We'll go into the different types of performances, whether there is a crash modification factor or safety performance function here. This is the area where you're going to use either your experience or your training from the Highway Safety Manual using this tool. This tool is really a state of the art. It's got some really good features to it, and we've just made some changes just recently to it where there are some really neat things in it. I'll go into detail about what we've done. As far as the crash modification factors and what crash modification factors to use, you know, if you're familiar with the clearinghouse or federal FHWA's clearinghouse for crash modification factors, there's so many of them. Which ones to use, which not to use, and we can. I mean, that could be a webinar by itself, and hopefully we will have you know, some. I think there are some webinars set up to talk about crash modification factors. But here is what we've done here is for the different type of alternatives. If we didn't have a safety performance function, we selected the best crash modification factor for that particular type of intersection or alternative intersection. I just wanted to make that point. The tool, you know, it's a safety comparison, and it's really same level of effort as the Capex tool, with the exception that now you're doing HSM analysis, you know. So performs predictive safety analysis of at-grade intersection alternative control types and ramp terminal intersection. When we say ramp terminal intersections, it's the intersections at the ramp, at the terminal, you know, ramp locations. As I mentioned, Highway Safety Manual is all about this, and this is what we'll use the safety performance functions where we can, and if we didn't have them, we use the crash modification factors. So it's developed with a goal to be user-friendly again. So we don't want to go to the extent of, you know, I'm going to mention the spreadsheets, Highway Safety Manual spreadsheets, 1738 spreadsheets. You know, they were designed for Practitioner to be user-friendly, but there's some very, very heavy, I would say, or you know, you would need to go back and forth to the manual and figure out what you need to use, you know, for those particular type of spreadsheets to have a really good a solution or a really good output so you can use. the SPICE tool has been designed to do all of that for you when it comes to intersections. Now, this is not segments, so we're talking about intersections, and it's the intersections tab in the 1738 spreadsheets that are kind of a little bit more cumbersome. But what you're going to see with this tool is a more how should I characterize? It's more user friendly. It's not a black box. You know, I would say that there's a lot of formulas that interact with each other based on the input, but it's a straightforward process. You know, if you understand the highway safety manual and safety performance functions and how crash modification factors are applied, you shouldn't have any problem with this spreadsheet. So, because it allows simultaneous evaluation of all the alternatives. You know, you don't have to go to each alternative and do it. It's going to give it to you right away. Again, the SPICE tool, what we did, and again, the FHWA is working on the SPICE tool also, but we took the initiative here in Florida to move forward this with the SPICE tool and develop it and have it available for Florida even before Federal Highway has it published. So here's a kind of flow chart or the process of how we develop the SPICE tool. So it's going to be using obviously the predictive safety for alternatives. And if you have an SPF or not, okay, so if you have an SPF, you apply the SPF, and based on, you know, either the existing or future condition, if it's similar to the existing configuration and crash data is available, you know, you go to the EB method. And if you know what the EB method is, you're going to do expected crashes, not predicted crashes. That's the difference between that yes and no on the left-hand side. On the right-hand side, if you don't have an SPF, you use a CMF. You know, you can use CMF with no crashes, or if you do have crashes, you can apply the CMF, and you can see the difference by using the crash modification factor. So either way, you can do the safety analysis, but preferably with SPFs. And I can tell you that Florida right now is in the process of developing an SPF for our cuts. FSU is actually doing that. Florida State University is doing the research for us. They're about halfway into it. We should have an SPF for unsignalized and signalized arc cuts by February. So that SPF would be incorporated into the tool after we get the final report. Just to kind of give you an FYI that when SPFs are available, we're going to include them rather than using the CMF, just because they're a better way to assess safety. Here's the introduction tab of the SPICE tool. If you notice real quickly, I'm not, you know, you don't have to read everything, but just the colors that we use is similar to the spreadsheet, the 1738 HSM spreadsheets. The data is required when it's the top color. The optional data is in blue. The planning level defaults in yellow, and the data entry field not used is dark gray. So here's a basic input that's the input sheet or tab. The at-grade intersection is evaluated based on the opening and design year. So you input those values on urban or suburban arterials. Number of legs, everything that you're putting in here goes into whether to use the CMF base conditions, the SPF, safety performance function base conditions, or the CMF values that are needed to compute the safety performance of the different types of alternatives. The opening year major and minor traffic, AADT, and design year. And then the control strategy, whether you want to move that forward or not. So there's a pull-down menu to include or not include that particular type of alternative based on the information that you have so far. In other words, if there's something that you know that I can't move forward, you just put no, and it would not do the computation for you. So here's the second tab. Now here's the tab where the stage 1 and stage 2 differ. In other words, whether are you going to use just stage 1 and do the assessment for the safety and end the process there, or continue with stage 2 and provide more detailed information so you can have a better assessment of what alternative to use. The Part C CMF values that you see right there, optional for use in stage 1, are the planning level information that you would need to put. And you can see some familiarity if some of you that worked with 1738 spreadsheets, you would see some of those CMFs that are needed for computing the safety performance functions for the intersection type. So lighting present, yes, no, number of approaches with permissive left turn signal phasing, an example. So those are the areas where you need to know the intersection type of from base condition to the alternative condition, and what do you want to use when you're computing the CMF. I'm sorry, the SPF. And here's again another, this is showing the roundabout, the control strategy, and some of the outputs for selecting the roundabout. So I'm not sure if you all know that there's a CMF for a roundabout that's used right now to estimate the number of reduction in crashes when you convert from a signalized intersection to a roundabout. What you see here is the input variables that are needed to compute the safety performance of the roundabout using the roundabout SPF. The roundabout SPF is not published yet, but we do have access to it, and we were given permission to use. So what you see here is state of the art, not even published yet, but Florida's using it because we want to not only be the first to use it, but we want to use it to assess and implement some of the strategies that we're trying to, mitigate for, crashes. Our Vision Zero is serious. We have a strategic highway safety plan that one of the goals is to reduce fatalities, reduce conflict points. This tool and this strategy and this is an initiative goes to do that. When you select these different types of intersection, you're actually eliminating conflict points and improving safety. So we wanted to make sure, first of all, that the safety performance function for the roundabout is a good safety performance function. It's been vetted, and it has been. Experts in the field have used it, but it's not published yet because it's in the final stages of the NCHRP report. But we asked Federal Highway if we can use it, and they gave us a heads up and a thumbs up, and you can see it right here in front of you. So we're proud of having it, and it's a big change, and hoping to see this used more often. We talked about the crash modification factors when safety performance functions are not available. And what you see over there is the default CMFs. So when we don't have an SPF, we want to use a CMF that makes sense for a different type of alternative. We've engaged our consultants and our universities to figure out which one is the best one based on, the number of studies that were conducted, when was it conducted, what star value it has, and such. So the default CMFs right there you see are the best of the best, and what we recommend to use when we don't have a safety performance function. And obviously the user can override that when a new study comes out that says, that is better or has a better star value. EB method, it's not new to the HSM practitioner, but we wanted to show this because you can do empirical Bayes analysis. You have to have 5 years of crash data. That's recommended, and it only applies to intersections with CMFs that are like the displaced left turn, the Michigan U-turn, and the R-cut, not the roundabouts. Because basically what you're doing is when you go to a roundabout, it's a different type of configuration, and you don't have the historical crashes to do an empirical Bayes analysis. Here's the prediction outputs based on, again, either the SPF or the CMF. It goes into the opening year, total crashes, fatal injuries, and then the design year and the total project life cycle. And I'll go into some of the calculations of that in the third tool, but that gives you the total project life cycle crash prediction summary. And then the ranking. So, the one is not going to be on top, but it'll give you the ranking based on the calculations of the fatal injury, FNI, and total crashes. Oh, there's some parameters that are exceeded, similar to the spreadsheet, 1738 spreadsheets, that kind of give the practitioner, hey, heads up, you're out of range of the AEDT, use this cautiously. So we have this similar cautions there to the practitioner. So if there are some data or there's some AEDTs that are out of range, then you're notified of that. So what does a SPICE analysis tell you? Allows decision makers to conduct a preliminary safety analysis of viable alternatives. Automates the predictive safety analysis. It's automated. It's fully automated for you. How can this data be used for alternative intersection control evaluation analysis? Provides a quantitative assessment and a quantitative. There's no quality here. It's a quantitative safety comparison of the viable alternatives. And in the form, you basically put, and I'll show this here shortly, you put the rankings in the form where it goes, so the managers or approvers would know what to look for in the ranking and how it's been computed. And what's the difference between stage 1 and stage 2? Part C CMF inputs are optional for stage 1, but required for stage 2. So again, HSM users or practitioners, Part C, Part B, and Part D of the Highway Safety Manual. And if any of you have not had that exposure to the Highway Safety Manual, the department does provide training for that. So, if you want to get either your district safety engineers or central office safety engineer. They will provide that information for you so you can get some training in highway safety manual methodologies. But Part C is really the strongest. That's site-specific safety performance evaluation, and it's the strongest of all the parts of the manual because it gets into particular sites and does not do, I would say, network screening level analysis or any of that stuff. And here's the input value in the form for the SPICE ranking. That's where it goes. All right. Any questions before I go into some of the input values for the next tool?
There's no questions in the chat right now. Someone asked if the presentation will be posted somewhere. Yes, on the Tampa Bay Traffic Safety webpage. If you follow your link that is in your invitation that got you here, then you'll see the hyperlink to that. That's where the presentation will be posted.
Okay. All right. Awesome. And on time, we're kind of. I'm almost here at a stage where once I go through the Synchro, I don't want to kind of. This is not a traffic operations training class, but I just wanted to point out some of the things in Synchro and what you need to do. We can go into detail if you want to attend the training at the districts, but I'm just going to cover a few things in Synchro and what do you need to know about Synchro, using Synchro for the next tool. So what we've done is we developed some templates for the practitioner to use for these alternatives. And these templates are available on our website. You could download them. They're configured. They have a basic configuration for that particular type of alternative. So the practitioner, when downloading that template, of course, let me just say those templates can be used in version 9 and version 10 of Synchro. So you need to have one of those versions to make it work, and it includes the proper default signal phasing and saturation flow rates. That what I say by proper, I'll show you here in a little bit, because there are some parameters where we don't want the practitioner to kind of exceed or change because they are just standard practice here in Florida. So let me see some of the information contained in the traffic analysis handbook and the quality level of service handbook also refers to some of Synchro analysis, but the practitioner, from that standpoint, what you need to do is just you're after the travel time delay. You're after the delay of the intersection. So you're going to get you're going to make some changes to the configuration of the Synchro template based on the roadway geometry, based on the phasing, and then get the delay of that intersection, and that would be the input value for the tool. We wanted to lock the default Synchro values, so we would have a consistent. In other words, District 1, District 2, and District 3, all districts would have a consistent output based on the geometry and based on the traffic control configuration. So that's why these default Synchro values are locked, and that's what the peak hour, the saturation flow rate, the lane utilization factor, and the heavy vehicle portion. Now that, of course, is changeable because that changes depending on the site. So it is for the more detailed operational analysis of the alternative. The need for the Synchro, again, we're after modeling the alternative intersection to Synchro only to get the delay that is needed Now we need to make it work. In other words, we just don't want to input the values in Synchro, configure the lanes, and then hit optimize. No, you actually need it to work. In other words, you cannot starve the side streets. You have to have a decent level of service throughout for the whole intersection, so you can have a meaningful output when it comes to using the delay parameter or using the delay outputs for Synchro. We wanted to make this, available for the practitioner, so you don't have to go and recreate it every time. Again, making it easier for the practitioner. The latest highway capacity software does include the MUT, RCUT, and the DLT as an alternative intersection for determining the delay. You can use the HCS, but if you are going to use the HCS, what you need to do is just print out the HCS sheets once you have configured the intersection and include it in your report. Obviously, Synchro or Synchro does not really perform a good analysis on roundabouts. So roundabouts is one of the things that we use, and we configure the delay using Sidra. So Sidra is the software that's preferred to use for calculating the delay of roundabouts.
Alan, there's a question about the Synchro inputs.
Yeah.
In Synchro, complex intersections have multiple intersection heads. For the overall intersection delay, are you suggesting that the users come up with a weighted overall intersection delay or a delay for each signal head?
Yeah, very good question. Okay, I was going to show that in my next slide, actually. So, yes, you're correct. For every signal head, there is a delay that needs to be aggregated throughout the configuration of the intersection type. So you have to add them. We've made it easier for the practitioner to do that by using here where I show is some of the delay that you would see for an RCUT for a particular head. And this is the timing that you would need to do. But where I was going with this is, let me show you here. This is the sheet that we've created so you can aggregate the delay for each signal head. It's already developed for the practitioner and how to use it. So very good question. Let me go back here just a little bit, just so I make sure I covered everything. I don't want to spend much more time on that, but again, the different types that we have, templates available, they're configured just in a basic configuration. You have to go and change them to match your site design. Here's the number of lanes, storage length, link speed, and channelized right turn lane, etc., that you would need to change or modify based on the conditions for the future conditions. And you need to make it work. So, you would actually have to design or, determine the timing plan for it and the cycle lengths. Now, what's nice about the RCUTs is that they're two phasers, and you have, you got to, they're, each one of those rows that you see is a signal head. So you just, it's a two-phase. It's no brainer. You can just calculate how much time is needed based on the volume that you have. So this is some of the input that's also required, or you need to consider when you're doing a jug handle. You can actually, this slide shows a quadrant southwest, but if you do have a quadrant that is, northeast, you can just switch it by using this dialog box right here. And then this is the spreadsheet that we created for the practitioner, so you can aggregate or accumulate the delay for that intersection. All right, real quickly, we're going to the FDOT ICE tool. That's the last tool that we've put everything together, which is, outputs from the first two tools and into the input of this tool. And basically, it's required in stage 2. So what we're doing here for the analysis to make sense is we want to do a life cycle cost analysis for intersections and come up with the BC, right? Bottom line, or benefit cost analysis based on both operations and safety. So this tool puts everything together for the practitioner to come up with that BC amount and make or provide the practitioner with the tools to print out and put into the report the BC for managers to look at and discuss, because that's basically going to be the justification for selecting that particular type of alternative. So we designed it it's a benefit cost. We designed it, not to take hours and days, but it's based on the inputs, and you're going to have some data to make this work, because I'll go into it, some assumptions that you need to, if you don't have the data, where to get the data to provide for the tool to be useful. Here's kind of the overview of what we're doing here. So we kind of putting everything together. And again, the operational analysis based on, the Capex, the safety based on SPICE, all goes into the FDOT ICE tool. You get present value, of the change or the benefit, present value, and the BC and net present value. Cost calculations for the life cycle of 20 and 100 years, so the right of way. Yes. Is there a question? I'm sorry. Okay.
No.
Go ahead.
Well, there was a question about the CORSIM. Is vehicular delay from CORSIM accepted in the delay calculations back where you were talking about that?
Not at this point. We might consider it later on, and I know CORSIM has pretty much the same highway capacity manual methodologies to compute delay, but it's more of a corridor analysis versus a single isolated intersection analysis. And we were talking about, I didn't mention, but we were talking about, well, what if PD&E is doing a widening of a roadway and looking at the feasibility or looking at what if scenarios and purpose and need. So take this scenario, and then I'll come back to your question here. So if you're changing a 4-lane divided road to a 6-lane, and you have intersections, that's a corridor study. The question is, okay, if I switch all my intersections or redesign the intersections to a more efficient traffic control operationally and safety by either utilizing arc cuts or other alternatives, can I not go through a widening project? Because inherently in these designs you do improve operations, and you won't have the delay for the corridor. So in that particular case, CORSIM or a Synchro model, or even a Vism model can be used to justify that. That makes sense? Okay. So we took this tool from something that's already been put together, which is the NCHRP 3110 Lifecycle Cost Estimate tool. It's pretty fairly new. I think it's only like 1 year old, and it's macro based. And we took that, we modified it for Florida. So what do we do for Florida? We took the peak hour volumes and developed a volume profile, a monthly volume profile for Florida to be used to compute the delay, based on the different types of alternatives that are available and what you select. It's a really cool tool. Until we got the Florida specific profiles, there was a suggestion to use the national profile that was developed a while back. We had some questions about that because it's not really Florida specific. So we waited until we got and we got it from the Transportation Statistic Office. They helped us out create that, so it was a really good effort. It was quick. In 2 months we had it, and it's really eye-opening to see some of the volume tables that nobody has thought about developing. So I mean it's an eye-opener for us. So we're really excited about using that. That's part of this tool, and we've customized it to improve or simplify and improve the input sheets. There are some local default values and performance measures that we had to make sure that they are consistent and where they came from. And again, the Florida specific volume profiles. So here's a screenshot of the tool. It goes into the AM and PM peak hour, and what specific month and day is selected. It's the analysis base. Select facility type, whether it's urban, arterial, or other. That's where it's going to choose in the volume table what facility type it is to compute the delay. And then the opening and design year. So I mean, where you see a show high detailed demand profiles, you can see that if you click that button, but that would be the Florida demand profiles. And then here's your alternatives and control types that are set up to work in the worksheet, and it would compute everything for you for all the alternatives that you would move forward. You could include or not include the different types of intersections. The design, construction, and right-of-way costs are areas for input. So practitioner must come up with those. Now there are, I mentioned earlier that some of the construction costs available for these alternatives are available from the documents or from the resources FHWA has. But we are also working on getting a more recent estimate of construction costs, and we're also working on a design cost too. We just asking around, asking other states what they're doing, see how many intersections that they've built. What's the cost of them? What's the design cost? The right-of-way cost, we're talking to the right-of-way folks about getting what we call a conversion factor. So the practitioner would use the property appraiser's website, cite specific cost, or I would say worth of value of the land. There's a conversion factor that that right-of-way uses as a preliminary estimate for acquiring the right-of-way. That will be utilized to provide the right-of-way cost if there's anything that needs to be acquired for the new alternative intersection. See, of course you're going to need the crashes, right? So the fatal and injury crashes for each intersection, and those are attained by, of course, what you get from the SPICE tool. So this is the input from the SPICE tool. This is the delay inputs from the Synchro files. And here's what you're after. Here's the bottom line. I mean, it basically shows everything in detail for the practitioner to print out and carry forward and present in the report. Real quickly, I'll just go over these. So you have, the planning, construction, and right-of-way cost for each alternative. Now we have to start from someplace, right? So we're comparing it from whatever it is now, whether it's a minor street stop control or signal or traffic signal. You have to compare it to something. So what you see there is the comparison is what we have now is the minor road stop. We're comparing a traffic signal and we're comparing a roundabout. So the post-opening cost, the auto passenger delay, the truck delay, and the safety. We put in a placeholder for the greenhouses and greenhouse gases and the pollutants, but we're not implementing those yet because that's just inherently in the tool that was there with the 3.110. We're not using it right now, but it's there to be used maybe in the future. So those are the total costs. You go down to the comparison now using the net present value of benefits. The safety is comparing the safety with the existing safety. So it's a negative number because safety has a value of 5.7 million, comparing to a value of 13 million and 14 million for the roundabout. So obviously you're going to have a negative number there. And if you go down to the net benefit cost ratio, you're seeing the traffic signal and the roundabout competing, and the roundabout comes out better. So that right there is the bottom line. That's presented with the study, and the study is like any other traffic engineering study, got to be signed and sealed, and available for going to the next step, which is implementation. This is another way to present it. Just shows you the different costs and how they're comparing to the alternatives and what comes out. The lower, the better. Okay, so the FDOT ICE tool is, tells us it comparatively evaluates the alternative intersections to provide the benefit cost and net present value for each. Bottom line. The operations analysis and delay is one, the crashes per year is the other, and the construction design right-of-way is the other. That's what's needed for the tool to work. And the benefit cost ratio for the delay, safety, and overall are reported on line 6169. So that is where you put it in the form, and that form in stage 2 would be signed by the district traffic operation engineer and the district design engineer. And what you need on stage 2 ice forms that ice tool does not tell? The total control strategy to be recommended, as other factors needed to be considered. So if there is some, I would say, near or close BCs, and you're not sure which one to use, then you would go stage 3. And in stage 3, there are other considerations that you would need to think about. Right-of-way is one of them. Environmental is another. Obviously, public input is another big one. And stage 3 ice form, it's just a form that you would have to include that information in to make your selection. And with that, any quick questions? I know we're getting close to 12 o'clock, so any questions?
Yeah, the outstanding question in the chat at the moment is what ICE, it appears to be kind of geared towards isolated intersection analysis.
Yes.
If you're working on a corridor, with 3 innovative intersections that you could consider, should 3 separate ICE evaluations be completed, or how does that play out?
Yeah, that's a good question. That's a question that came up in our preliminary training that we had here in central office, and this is the first development of this tool. Yes, it's developed for isolated intersections, but we're planning to step this up and use it for corridors also. But for corridors, you would need to have a little bit more information as far as land development, future traffic, and side street configurations, and other things that come into play that these tools are not designed to handle. So it is our first step, so to speak, and first of all, developing a tools and the forms necessary for the districts to use when they're making decisions on isolated intersections. But yes, it is an isolated intersection, but you can consider using the same methodology. If you're doing a PD&E and you have a corridor that you're looking to improve, or either operationally and safety-wise. So yeah, it's designed for isolated, but can be improved in the near future to include corridors.
Yeah, so in the short term, you would suggest maybe if someone was looking at converting 3 signals to R-cuts, which has a huge kind of corridor improvement, to just fill out 3 ICE forms?
Yeah, you would for each R-cut, you can use the SPICE tool. Obviously, you're going to a cost-benefit analysis. So, using the last tool, which is FDOT ICE tool, to do a BC. So you'll take the first one, you'll do the second one, and you'll do the third one, and you'd add up all 3 of them.
Okay. That makes sense. There's a lot of information here, Alan.
Yeah, yeah. Again, I know it's a lot, but we are going to provide training to the districts. Let me just say this to the audience: is that the upper management is very supportive of this. We are very serious about reducing fatalities and reducing severe injuries in Florida. And this is a very a step forward in that direction. So improving the intersections, not only operationally, which brings safety, with it, but also, evaluating the intersections using the latest tools and predicting crashes is really the future. So, yeah, go ahead.
I had a general question regarding kind of the whole program. Early on, you showed a calendar of sort of some dates and some commitments to study intersections, and kind of certain numbers of them that would be studied. That is not a commitment necessarily to build alternate intersections. That's just a commitment to study and evaluate them and make sure that the correct intersection type is being implemented.
Yeah, let me. I guess I wasn't clear on that, but for the first year, which is designed for or focused on training for the districts, we wanted to get some early successes, right? So, the public is not really used to seeing these, okay, in Florida. We've had a lot of pushback from roundabouts. So we want to have some success stories. So designing the right intersection, learning from lessons learned from what other states did, and building intersections that actually operate safely is our objective and motive here. So first of all, we do want to, not every intersection is suitable for this. So we want to choose the intersections that first have an operational issue, obviously, and have a safety issue. But when we know what the operational issue is, because we can figure that out right away, we have the tools to do that. What we don't have is the tools to screen for safety concerns, okay? So in other words, what I mean by that is what we've done so far is hotspot, reactive safety improvements. We go where the hotspots are. We don't consider the regression to the mean. We don't even address any of that. We just go to the hotspots, and whatever we didn't use at that intersection, we just throw everything at it. Well, it's costing us money, and it's not reducing our crashes or fatalities. The smarter way to do things is proactive approach for safety. So we screen intersections. What I mean, we screen intersections. We have to have the data, and we do. We're getting the data to screen these intersections to figure out which ones are susceptible to an engineering countermeasure. Not any of the other E's, but engineering countermeasures. This is what we call an excess expected crash frequency that pops out from a network screening exercise. So those are the ones that we want to capture for improving safety. And like I mentioned, the operations we can see it right there. So those are the intersections we will screen and choose for the districts, and we'll work with the districts if they have some recommendations too for selecting the intersection. And then we'll implement what's the best solution for that intersection based on the context, based on the operation and the safety benefits of these alternatives. So.
I guess give folks a moment here to see if there's any other questions that come up in the chat. Yeah, in the meantime, I guess it's just everyone keep posted and keep looking for info. If you're in the District 7 sort of Tampa Bay area, I know that the ICE Tampa Bay user group is being formed, and I'm assuming that there's coordination between your office and District 7 regarding the training and all that. I mean, the user group in Tampa Bay would be the people that would be at that training.
Yes.
I'm not aware of any other districts that are forming user groups, but that's kind of what the training is going to do, is identify the people that are going to be doing all this analysis and
absolutely, yeah, and I mean, I applaud District 7 for taking that initiative and putting together this working group. We're supportive of them. I know Peter Shu has been instrumental in doing that, and we work closely with Peter to let him know when the training dates are available. We did have some initial training dates, that were part this month and January, but we had to change them because we went from a 1 day, compressive in training to a 1 day and a half, like I mentioned, where we would have a half a day for managers and a full day for analysts. So they would know, how to get them guidance of how to, and hands-on training on how to use these tools and go through the evaluation. Yeah, and let me mention also is we're working on, I would characterize it as a practitioner's guide for intersection control evaluation. So I mentioned that the design cost, the construction cost, the right-of-way cost, that's so fluid that, we need to get a better handle on it, on estimating design and construction. Right-of-way is another animal, but, that practitioner's guide is going to introduce some good information from not only other states, but from designers themselves as far as what it takes to put together a set of plans for these intersections. What are the best practices? What's good, what's not good? Similar to how you design roundabouts. We want success stories right away in Florida. We just don't want to have one of these intersections designed poorly and then use that, or the public use that for hey, see, we told you that's not going to work. No, we want them to work. So that information is pertinent, and we are in pursuit of that. So that will be coming this coming year also. So it's watch for it. It's called the Practitioner's Guide for Intersection Control Evaluation.
Yeah, so I mean the other questions that are popping up in the chat are just people interested in the training. So I mean, I guess just be on the lookout for those notices in District 7. They'll be posted on that website, the Tampa Bay user group, and we will be creating a link on there so we can start building an email list so that the people that are interested in that are in this area can be emailed that information. Also, right on that page, I put a link over to the Intersection Operations and Safety webpage, FDOT's page. I don't know, I can share my screen real quick and show
Sure, please
everybody
do.
That's on the line where these forms are available. Share my screen. I'm sharing my webcam as well, it seems. It's not what I intended to do. Make presenter, show my screen. There we go. Alan, are you able to see the web page?
Yeah, that's our web page actually. That's
Yes,
central office.
That's what I intended to show is your web page.
Yeah.
This website here, I put a link to that off of the Tampa Bay Traffic Safety page. But if you Google search for FDOT ICE, it takes you to this page, and the manual is here, the ICE forms are there, Capex is here, SPICE is there, and the FDOT ICE tools are here as well. So all the information that Alan went through today, all the spreadsheets are available here for people to, play with and use. Be familiar with them, and do some homework prior to the training so that we can ask good questions and really get good value out of this information. But it is all right on FDOT's page. On the Tampa Bay Traffic Safety site, the links for that, depending on which page you're more familiar with, I put links here. I mean, this takes you right to the page I was showing you, and these are links that take you back to the, back to the FDOT site. You were going to say something, Alan?
Yeah, make sure they link to that link that we have, because as one of the audience mentioned that one of our tools does not have the context zone, I think C4 in there. You're going to have that updated, with probably tomorrow. So we'll have it in there. It's just probably not the lookup table is not stretching down to C4 yet. So that's an easy fix.
Okay.
So if you're linking to us, you'll get the latest.
Yeah, what they were talking about was this right here. C4 is missing.
Yep.
It goes from C3 to C5.
Yep.
Now, when you update your spreadsheet, will the file name change? I guess it'll be a different date, right?
Yes, it'll be a different date. Yeah, but it'll be.
Okay, so what I probably want to do then on my page is to remove the specific link to the form and just have the link to the page.
That's
so
correct. That's what I was.
Download the recent one. Yeah. Okay,
Yes.
I'll do that. Because I don't want people downloading the older version, out of my page, and then I'm responsible for incorrect analysis out there somewhere. Let me check again real quick if there's any other questions. If not, then we can adjourn our meeting here. Yep, that's there's nothing else in the.
Hey, Alan.
Nothing else in the chat.
This is Dennis.
Go ahead, Dennis.
Alan, this is Dennis. I wanted to tell you, thank you so much for this presentation. Like Anthony said, there's a lot of material, but I think it's going to be very useful to a lot of folks, and it's good to hear about the user group being formed at District 7. And you've had probably close to 100 people, attendees. It doesn't count those that are multiple folks in various rooms within the webinar, because some people log in and maybe 3 or 4 people might join them in a room. So it was well attended. And
thank you so much.
Very good.
Yep. Well, thank you so much, and thank you to all of you attendees. I would like to say that watch out, look for the training that's coming your way. If you have any other questions or something comes up later on, please don't hesitate to contact me or send me an email, and this is exciting time. So we're looking forward to not only the FDOT and the districts moving forward with this initiative, but also the locals. So good luck with it. And again, we're here to support and provide guidance and help you with this process.
Okay, well, thank you so much, Alan. I guess that concludes our webinar. I'll end the recording now, and we'll stay on the line for a few seconds if anybody else has anything else that comes